Huh? That's because you didn't do it. I know.
I did both. It wasn't that bad.
Good.
8.4, it was easy.
I'm still catching up.
Say 8.4 was easy. I did good yesterday. Because that's typically not very easy.
Oh, wait. No. I have question number 37 on the answer.
You probably want to keep that paper.
We got a top 60,11.
Yeah.
They want to know the details about this vector, correct? Ooh, they call it vector. I call it vector U. I'm so sorry.
I'm fatally offended.
Oh, let's see. 61?
Yeah.
So the magnitude of B is 61. That's a Pythagorean triple. 11, 60, 61. You didn't know that one?
Yes, I did.
Yelling at me? What are you talking about?
Yeah.
I do. All right. So, do we like where the vector is? I do.
Yeah.
Why do I like where the vector is? It's first quadrant, so I'm not going to have to worry about messing with any angles and stuff like that once we... In other words, reference angle is our answer. So, if we were to draw it...
Wait, they want the unit vector.
They want the unit vector?
Yeah.
Gotcha. Oh.
Is it
So-
60 over 2? Okay, but in the book it said 60 over 11. And I was confused. Okay, that's what I thought.
No.
Okay.
Cannot be, because as soon as you go 60 over 11, it can't be a unit vector anymore.
Okay.
You know what I'm saying?
Okay, so then I don't have a question.
Okie dokie. Yes, mega typo. The components, each of the components will always have to be no greater than 1. And the only way it could be 1 is if the other one is 0. Any others? Yeah, that was a homework question. Number 37. But there's a typo in the back of the book. There are a lot of typos in the back of this book. I just spent the last 40 minutes today working on typos on the exam review. Something got changed within the last few years, like we changed some of the questions around on the review. We didn't change the answers.
Makes sense.
And you knew immediately that something was up because there were 55 questions on the review, but there were 60 answers. So the answer to number 56 was B, except
It's a word
there
problem.
was no 56. Interesting. So that's what I had to figure out. All right, away we go. Yesterday, towards the very end of class, we talked about unit vectors. Correct? What is a unit vector? I don't like the second word you said. A vector
With the magnitude of 1.
with magnitude of 1. Which direction would a unit vector go in?
Any direction.
Any direction. It can go at any angle. But that being said, there are two specific unit vectors. Captain, there are two specific unit vectors that become very important to us, and we will use quite a bit. One of them is a unit vector that goes horizontally towards the positive x-axis. And the other one, I'll bet you can figure out, is going to go vertically on the positive y-axis. The horizontal unit vector we will call I, the vertical unit vector we will call j. And to answer your question, no, it does not have anything to do with an imaginary number
Thank God.
yet.
Yeah. I don't like that face. Which means you just haven't given us a problem yet.
This is where we are today. Complex numbers. Polar forms.
There's eyes.
That's the best news. The best news is that we're going to deal with i's in 2 or 3 different ways. One of them will be an imaginary number, another one will be a vector. I didn't make it up. So, if we have vector u, and we say that vector u in component form is 4 and -2, they will ask us to write the vector. Rats, I left it on the wrong page. Rats. They will ask us to write the vector, you getting there? Hang on. In terms of unit vectors I and j. In other words, 4 i's minus 2j. So instead of writing the vector like this, we're going to start writing it like this. So if I tell you about a vector that is -3i plus 2j, what am I telling you about the vector?
-3.
It's going to go 3 units to the left and 2 units up. That's all. So don't over stress about this. It's just another notation. It doesn't change what we're doing or anything like that. In fact, the first few questions of your homework are going to say, express this vector in terms of the unit vectors I and j. In other words, do that. We like those. That's easy, right? Okay. What happens if we have another vector, we'll call it vector v, and vector v is -6, 1. How would we write v in terms of I and j? -6i plus j. High-level stuff so far. They will then ask us at some point to add vectors u and v. We're really jumping up now. Be careful. -2i minus j. Are we okay with that? What is u minus v? Thank you. That's why I asked it. You guys okay with that today?
-10i. Oh wait, nope.
How is it negative?
I did v minus u.
It's positive.
Yeah, 10i.
10i
10i minus 3.
minus 2j. Sounds good. How are we doing so far? I minus 3j.
Oh, I
minus
think I know where this
negative
is
2i plus j. What are we actually doing here? Subtracting two vectors. Doesn't look like we're subtracting two vectors, but that's exactly what we're doing. If we subtract the two vectors, what do we get?
3i.
3i minus
4j.
4j. Yes. That is the new material of the day that we needed to go over. Yes. The applications that we were about to start are by far the hardest part of today's stuff. This was, I could have taught this on August 8th and you guys would have said, oh yeah, that's no problem. You might not have. You probably would have gone, oh no. Question number 64, very top of the screen. Plane has a compass heading of 30 degrees east of due north and an airspeed of 400 miles per hour. The wind is blowing at 30 miles per hour with a heading of 60 degrees west of due north. What are the plane's actual heading and airspeed? Okay. These are vectors.
No idea.
And this is why we use vectors. Okay? We use vectors so that we can solve problems like this. Okay? Now clearly, we are getting into real-world scenario areas. So what do you think we should do first? Draw it. I would agree. I would absolutely draw it. Since as I read the problem, I see lots of north stuff and nothing south, I'm gonna draw my graph. I'm gonna draw my picture like that. Is that okay? Don't need the bottom stuff too much, just need the top stuff. So, the plane has a compass heading of 30 degrees east of due north at an airspeed of 400 miles an hour. We should draw a
Vector.
We should draw a vector. Where should we draw that vector?
30 degrees from.
East of
30 degrees from here? 30 degrees from here?
Yes.
Which way?
Right.
To the right, east of due north. So we're doing a vector. Is that fair? Is that a fair looking vector? Okay. You know what? I'm going to a little more angle to that vector. Let me do that. That's probably a little better. Okay, tell me about that vector. So this is 60 degrees, and this is 30 degrees. Is that okay? Anything else we should know about the vector? Okay, so what does that mean? It has an airspeed of 400 miles per hour. That's the magnitude.
It is magnitude?
Yep.
Well, it's a speed, huh?
Because it's.
I heard him say that's the magnitude.
Oh, okay.
Yeah, he said.
So, there's our magnitude of 400. Are we okay with that vector?
Yeah.
Okay, it has a magnitude of 400. It is 30 degrees east of due north. All right, now let's talk about the wind. The wind's going to blow 30 miles per hour with a heading of 60 degrees west of due north. Tell me about it. Can I draw it from the origin?
Yeah.
Okay, we'll draw it from the origin. So we're going west, so we're going that way? So is it pretty much up like this one was? No, it's more down here. Okay, and it's just as long as this vector, right? Why not?
30.
The wind's only 30 miles an hour. Plane's going 400 miles an hour. The wind is only blowing 30 miles an hour. Will the wind affect the plane?
Yes.
Yes. Will it blow it from Chicago to Seattle?
No.
No. You know a map of the United States? If we were flying from here, if we were trying to fly from here to Chicago, would that wind be strong enough to blow us to Seattle instead? No. It'll have an impact. But in this case, it won't have a major impact. Why not? It's only going 30 miles an hour. If the wind were blowing 300 miles an hour, we'd have a big issue. Which is why planes don't tend to fly in 300 mile an hour winds. Okay.
That would be fine. Just imagine.
What's this angle right here?
30.
30 degrees. What's this angle right here? 60 degrees. Okay. So wait a minute. If this angle is 60 degrees and this angle is 30 degrees,
That's a 90 degrees.
then we end up with 90 degrees between those two, which might be helpful to us as we go on. What's the magnitude? 30, because the wind is blowing at 30 miles per hour. What are we going to do with the two vectors? Think it through for a second. I've heard many answers. I have heard the correct answer, but I just want people to think about it and talk about it for a second so we kind of understand what's going on. What are we going to do with these two vectors?
Make them into a single triangle.
Why subtract? Yeah, but let's say that we are subtracting numbers that are going in opposite ways. Then we're actually adding them, aren't we? So how do we deal with numbers that are going in opposite ways? That was a very good question.
Yeah. I don't know. That's me.
If we add numbers that are going in opposite ways, then what ends up happening? Then we end up kind of subtracting, they end up kind of canceling each other out. Unless they say something specific, we are typically going to be adding vectors. Okay? Because there are two different things going on here. What's the first thing? The plane is flying. The second thing, the wind is blowing. Are they both happening? Yeah. So if two things are happening, what would you typically do with them? Add them. Does that make any sense? So both of these, and I would consider these forces. Our first force is the plane going 400 miles an hour. The second force is the wind going 30 miles an hour. Okay? We add the two vectors together to see what the result is. All right? How do we add two vectors? Yeah. We're going to take the second vector and attach it to the end of the first vector. So we're going to take this little vector and move it up here because this is the end of vector number 1. And that's 30 miles per hour. Does that make sense? Okay. How do we draw, or what is the result? From the origin, why from the origin? That's where we start, to
30 miles per hour.
so we follow vector 1 out, we finish vector 1, then we start vector 2, we go to the end of vector 2, and that's where we finish, right? So, from the beginning to the end, the red vector is the resultant vector. We have a triangle? We have a right triangle. We have a right triangle? Okay.
Like it's 30.
Great question. How do you know it's right?
The 30.
All right. And my answer to that is going to be multi-part. The first thing is, most of our angles that we create here are not going to be right angles. We just happen to pick a question which will be similar to the one you have on your homework, which happens to be a right angle. So that makes life easier for us. How does it make it easier? Because now we'll be able to use Pythagorean theorem and we made up the word
Oh, SOHCAHTOA.
SOHCAHTOA. When we have a right triangle, we can use Pythagorean theorem, we can use SOHCAHTOA, that makes life easier. If we didn't have a right angle, law of sines, law of cosines, perfect. The question was, how do we know when we're going to use law of cosines? I assumed that that question meant as opposed to law of sines.
Yes.
Okay, how do we know that, by the way?
Law of sines is when you
Just from the
do the
first
same
side or-
letter.
Law of sines is when we are given
Two of the same.
two of the same. So SSA or ASA. Law of cosines is when we can't use law of sines, which would be when we're given
SES.
SAS or
SSS.
SSS. Good. To see what this angle is, and in this case we know, but in those cases that we don't know, what I'm going to do, okay, when we're doing a lot of this vector work, I'm going to draw little mini coordinate axes all over the place. That works best for me. So what I mean is I'm going to draw this, okay, where these two vectors meet. And I'm going to put all the angles in there, and I'm hopefully going to be able to logic out what that angle is inside the triangle. For instance, okay, do you know what this angle is right here?
60. Oh, yeah, 60.
Ready for this?
It's
I'm going to bring up some bad memories, perhaps.
Isn't it
Hopefully they're good memories, but they might be bad
because
memories.
it's 60 on that side, so it's 60 on that side.
This intersection?
Yeah.
So here we have
It's the transversal. Yeah. The two lines of the transversal.
we have two parallel lines that are cut by a transversal. This is geometry, which is why trig is what we do after geometry and algebra 2, because it does incorporate both things. If we have two parallel lines cut by a transversal, then what kind of angles are this one and this one? They end up being congruent, but why? Because they are, first word starts with an A, second word starts with an I.
Alternate interior.
Alternate
go.
interior angles.
Oh, I remember this.
Alternate interior angles are congruent. So if this angle is 60 degrees here, we follow the transversal up, we find the other parallel line and come over here. And this angle is also 60 degrees. I know, isn't this awesome?
Yeah, I don't remember
Exactly. Then we also have this top part of the angle, which you think is 30. I'm actually going to agree, because this angle
Same as
is with this one right here, right? They are both above and left of the origin. Wait, they're both in the same spot. What are they called? Corresponding angles. And corresponding angles are also congruent. So if this angle is 30, then that angle is also 30 degrees. And so now we have the 30-degree angle and the 60-degree angle, which combine to form a right angle.
Or you could choose what you drew before.
I don't want to look at that anymore.
My point is, this one works out very nicely because it's right angle. Most of them that we see as time goes on are not going to be right angles. So you're going to have to find ways to figure out what the angle is. And for me, I will just draw lots of coordinate axes. And I will do exactly what we just did right there. And eventually I'm going to come up with what that angle is. Now, in this case, give me a second. In this case, we're 30 degrees east and 60 degrees west. So we're kind of 30 degrees one way and 60 degrees the other way. So we would add those two together, and that's where we get our 90 degrees. Fair? But let's say that we were 30 degrees east and 50 degrees west. Now we are 80 degrees. But, fair warning, if it says 80 degrees like that, 30 degrees east, 50 degrees west, 80 degrees, more often than not, God bless you, more often than not, our angle is not going to be 80 degrees. Listen to this. More often than not, that angle is not going to be 80 degrees, it's going to be 100 degrees. More often than not. More often than not, it's going to be the supplement of that difference in the angles. So, what becomes important is how you draw it, how accurately you draw it. Do your best to be accurate here. Because if you draw it accurately and you see that it's an obtuse angle, and your angles are 80 degrees apart, then the angle measure in here is probably going to be 100 degrees, because it would be 180 minus 80. So this angle in here is either going to be the difference in the angles, or 180 minus the difference in the angles. And how you draw it is going to be important there. You had a question before, Matt?
No, that was.
Okay, that's what I was thinking. That's why I said hang on a second. So be careful about that. That's by far the biggest issue that we have here. Once we get this, it's not easy, but it's more straightforward. We now have a right triangle. What are we trying to find? Two things, right? First thing, I make that the second thing, but that's fine. Magnitude is first. Can we find the magnitude here?
Yeah.
How?
Pythagorean theorem.
Because
It's a right.
we have a right triangle. Pythagorean theorem is wonderful. So, 400 squared. Wait, which one's the hypotenuse? Black or red?
Red.
Red. So 400 squared plus 30 squared. Take the square root, and that will give us 401.1, is it?
Yeah.
0.1. What did we just find?
The magnitude.
What does that really mean in this problem? The speed. It's how fast the plane is going with the wind added on.
So it's going to go faster?
It's going to go faster because it's trying to fly this way, but the wind is blowing it this way. But it's basically trying to go up, and the wind is kind of also pushing it up a little bit. Not much. You know, it's more perpendicular. It's totally perpendicular, but it's going to help the speed a little bit. Not a lot, but a little bit. If the wind were blowing, instead of blowing like this, if it were blowing like that, now it would have slowed it down.
Oh, okay.
Okay? So the direction there becomes important. 401.1? Cool. Now what? Okay. Before we find the direction of the vector, because it's really going to be a two-part issue here, what do we have to find first? What are we working on right here? A triangle. We're working on a triangle. Let's find the angle of the triangle. And then we'll see how that applies, if it applies, to the direction of the plane. Let's find the angle of the triangle. Which angle do we want to find? The bottom one, the little dinky one on the bottom here. That guy right there? Okay. How are we going to find that angle? Tangent
Of third
of tangent of
theta.
theta equals 30 over 400.
3 over 4.
Okay. Could we have used law of sines here?
That's
Yeah.
a pain in the butt.
It's a pain in the butt. I don't know why I would, because we have a
Easy.
right triangle, and since we have a right triangle, we don't need to use law of sines or law of cosines. Tangent of theta equals 30 over 400. Theta equals
4.28. Oh, 29. Yeah.
theta equals 4.3 degrees. Is that the direction that the plane is flying? No. What is that?
4.3 degrees less than 30 degrees.
So it's the angle of the triangle.
Yeah.
4.3 degrees is this angle of the triangle. We want to find the red vector.
So it's 6.
So where do we want to relate the red vector to?
30 or 6.
That's a weird question to ask. That was very
The angle of the black vector.
well, we already know how it relates to the black vector. I'd like to figure out how it relates to north.
30 minus
You know what I'm saying? And you guys are all saying the same thing. You're all doing it right. So I'm phrasing it a little bit differently than you.
25.
But we are 4.3 degrees less than 30 degrees away from due north, right? Which gives us 25.7 degrees. What does 25.7 degrees mean?
The heading
25.7 degrees
East of north.
of,
east
of due north.
of due north. So tell me about the plane's movement.
Flying 401.1 miles per hour.
401.1 miles per hour.
25.7 degrees east of due north.
Perfect. Good. How we doing? You see how, I mean, obviously the first stuff that we talked about at the beginning of class was nothing major.
Right.
And this is clearly a much bigger deal, and I think you can see that. A couple things on the homework before I forget. The first question listed on your homework is question number 4, which seems silly because
It's all even.
that's even, and we already did all the lower ones. I'm pretty sure that was a typo, and it's supposed to be 45.
Oh.
So change that first question in your homework from number 4 to number 45. It's really a tough one, so that'll probably add 20, 30 milliseconds to your homework. Part 2 of what I'm going to say about the homework. I think the assignment's too long. Zap the last 3 questions, 75, 81.